the steps for finding R Thevenin. Okay, so R Thevenin is we're going to remove this R3 from the original circuit, and then from the perspective of A and B, what would be the resistance between A and B as far as R3 is concerned, or from the perspective of R3. So let's go over to a clean piece of paper or a clean sheet and talk about this. Okay, so I've defined my A and B points. Okay, and I'm going to use Thevenin's analysis to solve the circuit for R3. And so on this page, I'm going to do my R Thevenin redraw. Okay, so basically I'm going to remove the load from the circuit and pay attention to where A and B points are. That's where the load was. And so it's as if I'm taking my ohm meter and measuring those points with R3 removed from the circuit. And then now we have to, normally we wouldn't take a resistance measurement with the power supply connected, but that path through the power supply when the circuit's operating turns out to be important to the equivalent resistance that the load would see. So the way we deal with that in Thevenin's analysis is we short out that supply. So that supply is now just a path to ground. So now a good battery or a good power supply would have essentially zero resistance within it while the circuit was operating. So the AB resistance from the load's perspective would see that as just a short circuit from the points at which the power supply was connected. And I'll try to explain that as I go and see how that, hopefully that'll make sense in a second. Okay, so when I'm doing this analysis, now this is already looking quite cluttered. I recommend doing your redraws on a clean piece of paper. So reference your original circuit to see how things connect, and then come over to a clean piece of paper, and I'm going to leave this here, but I'm going to show you how I redraw the circuit. So now the first thing I do, especially if it's a new circuit or something, if I'm not quite sure where I'm going to go, is I'm going to draw the circuit without moving anything around. Okay, but showing all the steps for R Thevenin redraw applied. So where was my load? Well, my load was between here and here. Okay, so here's R1, here's R2. Alright, now look, I've drawn my path through the power supply just as a short or a wire. So here's my initial redraw. So I haven't moved anything around, I've just applied the steps. Okay, and then out in the literature will tell you the steps are open, and I like to say open / remove the load. Whoops. Okay, and then define A and B points. Whoops. Where the load was. And the load is just the component or network that we're analyzing using Thevenin. Okay, so define the A and B points where the load was, and then finally calculate. Well, actually, forgot one step. Short power supply. Okay, and then calculate. R Oops. Calculate the resistance between A and B. Alright, so that's what we're going to do. So basically we're going to measure, and you can actually measure this in your circuit, just where your power supply connects. Just take those two connections and actually short them together, remove the load, and measure from A to B. You will see R Thevenin, which is pretty cool to actually see that. Alright, okay, so basically that's what I'm going to do, but let me redraw this. Now look at my path. When I do a redraw, I'm gonna define my paths from A to B. So I've got one that way and one that way. Okay, so the first path is just through R1. So here's A, R1, and B is going to be down here. And my other path is through R2. Alright, so my R Thevenin is just going to be, so here's my final R Thevenin redraw. So it's going to be R1, which is 1 k ohm, in parallel with R2, which is 4.7 k ohms. Alright, so R Thevenin, whoops, equals, I'll show the formula, R1 in parallel with R2. Alright, I'll show my math so in case I mess up I can see what I did wrong. Alright, so let's just write out a place to put that. So R Thevenin, let me wake up the old calculator. Wake up, calculator. Alright, there it is. Alright, right in the middle of my where I'm looking. Alright, so I'm just going to type my formula right in, and then I'll look to make sure I got it in the right spot. Okay, so 1 divided by, okay, let's get a couple of parentheses in here, and 1k plus parenthesis 1 divided by 4.7k, and that all looks right. Let's check it, and I've got 824.6 ohms. That looks correct. So R1, R2, yes it does. So let's just, so one thing that's a little bit uncomfortable about Thevenin or other theorems is they're very algorithmic, and so that comfort level of double checking things along the way, that as you would with Ohm's law and Kirchhoff analysis, you don't really get that throughout the process, but I mean, you can still do that in the end, and you should. But right now, so basically, unless I just have to be very careful. This is a pretty simple circuit, so I can kind of see what I'm doing, but you got to be very careful to with your little math errors and arithmetic mistakes and things like that. Just kind of watch for those things. So there's our R Thevenin. Okay, so that's all fine and dandy. Let's go back to the original and see what else we had to